Welcome back. That was fast. Welcome to the second of this week's 3 videos. In this one, we're going to talk about self-regulated learning. So within self-regulated learning, as I mentioned in the previous video, and you probably just watched it, adaptive learning systems typically focus on detecting metacognitive strategies, metacognitive skills, and self-regulated learning behaviors. So you might say, what's the difference between these? And there are some differences, but the field often treats these like they're interchangeable. So MetaTutor, for example, also involves the self-report of planning and strategies. We saw that just a minute ago in video 1. One core SRL behavior, and probably the most studied, is self-explanation. In self-explanation, the student explains the content or the meaning of a text they've just read, or a result they've just obtained, or a step in a worked example, or really anything, to themselves and in their own words. And self-explanation can be prompted by adaptive learning systems. And it leads to better understanding. The classic paper on this is work by Mickey Chi, but there was a meta-analysis a few years ago that really hammered this in. And Chi and her colleagues noted in their classic paper that good students seem to generate explanations which relate to the principle stated in the text, as well as relating the consecutive example statements to each other. So the key point is that a good explanation connects things together in what you've learned and connects it to deeper principles. So the qualities of a good explanation: consider the conditions under which specific actions are advisable, infer the consequences of an action, and consider the meaning, in this case, of a mathematical expression, because both these papers involved mathematical or physics reasoning. Alexander Renkel also discusses identifying the sub-goal achieved by each operator and attempting to anticipate the next solution step. Chi and her colleagues in Renkel note that bad self-explanations, by contrast, simply rephrase the content. Just saying it a different way doesn't really engage in the deep cognitive processing that self-explanation can involve, or making trivial inferences. And perhaps it's in these differences between good self-explanations and bad self-explanations that we can start to think about why is self-explanation beneficial. Chi and Basak note that self-explanation helps fill in gaps in student knowledge that aren't immediately clear from the text or the worked examples. And Van Lane and colleagues note that by self-explaining, the learner rederives the process used to conduct the step and can then make analogies to that process later. Chi notes in one of her later papers that self-explanation, when students do it, targets to exactly what the student is struggling to comprehend. That when a student self-explains, they identify what they're having trouble with, and they can see if they can figure out how to understand it. And thereby, self-explanation can lead to revision of incorrect or incomplete mental models. Because of the value of self-explanation, a lot of people have looked at creating interactive scaffolds for it. Conati and Van Lane created these systems where students could build self-explanations with pop-up menus. And also by clicking on elements in a list of possible elements. Essentially building up their self-explanation piece by piece. In this scaffold, the student model is used to infer which steps the student doesn't understand, and then the student is required to self-explain those steps. So the idea here was that it's been established that the goal in self-explanation is to think about the things you don't fully get. So Conati and Van Lane use a student model to hone in the student's self-explanation time on exactly those things. In another example, Ritchie et al., they attempt to, and demonstrate benefits learning, to have students build up self-explanation through a set of relatively simpler multiple choice items. And like in the work by Conati and Van Lane, the student is only required to self-explain on the things that they still need to learn. Now, these multiple choice items originally were designed with the goal of just making it easier to develop them. And people thought, oh, self-explanation in natural language is going to be just so much better. And Levin et al. Tried this, McLaren tried it. It didn't seem to lead to any benefits over menu-based self-explanation, which was kind of surprising to the field. So self-explanation is one of the things that people really focus in on over time because of all the evidence that matters. But of course, there's a range of other important metacognitive strategies and skills. And many of the other common strategies and skills are framed in terms of a particularly popular pair of models of self-regulated learning. Both these models were developed by Phil Winnie and his colleagues. The first is COPES, which models self-regulated learning in terms of conditions, operations, products, evaluations, and standards. And Winnie and Hadwin model self-regulated learning as involving 4 phases. In the first phase, learners develop a model of the task by interpreting the task conditions, things like the contextual constraints and affordances, time limits, material resources, what help is available, and the cognitive conditions, like the student's knowledge of the task domain, memories of challenges with similar tasks, strategies that proved effective. In the second phase, learners create goals relative to their model of the task, and then they select cognitive operations as study tactics and learning strategies that they believe can contribute to achieving these goals. In the third phase, learners learn by applying these chosen tactics and strategies. And as they do, they try to see, am I actually updating my knowledge about the topic? Am I learning more about the topic? Is the strategy as helpful as I thought it would be? And in the fourth and final phase, um, they, um, they produce products, which might be knowledge or models or diagrams. They can be artifacts you could show somebody, but they also could be artifacts up here. And learners, as they develop these, may say, okay, this is good enough, or they may choose to revise those products. They also might decide to adjust their model of the task and adapt their goals and strategies accordingly, going back to earlier phases. So Winnie and Hadwin's model has been very influential. And one learning system, which I've actually mentioned a couple times before now in the semester, that's very closely built on Winnie and Hadwin's model is the QThink learning system, which goes through these 4 phases of scaffolding students in solving complex math problems. They frame the 4 phrases as understand, plan, solve, and review. And in these, QThink is a social learning environment, so they not only engage in these behaviors themselves by, for example, engaging in explanation activities and making a plan, but then when they solve, they create a video of their solution, and then the other students in the class and their teachers give them feedback. So not only do they review their own work, but other people participate in that review. The second very influential model of SRL is Winnie's SMART model. And clever people in the audience might note that SMART and COPES are very clever names. In fact, I actually talked to Phil Winnie about this at a conference in the not too distant past, and Phil was like, yeah, I actually came up with these ideas when I was preparing to teach classes, and I wanted to create a clever acronym for students to remember. Which is kind of funny that these have turned into such influential models. SMART consists of the 5 strategies of searching, monitoring, assembling, rehearsing, and translating. And Zhang et al. For the QThink system broke down these 5 overall strategies into some finer-grained strategies like numerical representation, contextual representation, strategy orientation, outcome orientation, data transformation, following the plans you make, and incorporating information. Nassiar et al. Added another one, strategy augmentation, where a learner goes beyond the strategies recommended to them to make up their own strategies. So okay, our system might have a list of SRL strategies we want to identify, and we detect them. What do we do next? A common approach to supporting SRL is providing messages to the learner when they're not demonstrating an appropriate strategy. And we saw examples of this in Levin's help-seeking tutor earlier in the semester. Another example is seen in Betty's brain, and you can take a look here at all the various things that Mr. Davis says to Betty. The Betty's brain system was found to be generally effective at promoting learning, and in particular, and this is kind of a contrast to Levin's results, Munshi et al. Found that hints that support debugging and assessment by the students are particularly strongly associated with learning gains. Another popular system for SRL support is CSM Learn, which provides data on student self-regulated learning to a human instructional coach, who then provides the SRL support in coaching sessions. One concern that's been raised about SRL messages, as they're typically done, and this was raised by Okampa et al., which was in press at the time of this recording, is that SRL messages in these systems often focus on what the student can't do. And they say, you're not doing X, a deficit framing, rather than focusing on what students can do, their assets. And there's ongoing work underway in many teams now to frame SRL messages in terms of what students have already demonstrated they can do in some situations. So in other words, instead of saying, you're not doing X, tell students, in the past you've done X, try it here. All right, so some key takeaways. Self-regulated learning depends on metacognition. and specific SRL behaviors can be positive and can be scaffolded. Self-explanation is a case for which the scaffolding approaches and the effectiveness is particularly well established. There's also possible examples for other SRL behaviors, but considerable work remains to understand, detect, and fully leverage SRL support so that we can help students become successful at regulating their own learning. Thank you. In the next video, I'll be discussing engagement.